Hello, everyone. This is the lecture for section 2.2, graphs of linear functions. So in section 2.1, I defined a linear function, right? The bits and pieces, we know what the slope is, we know what the y-intercept is, right? And we sort of found how to, like if I gave you 2 points, right? If we had 2 points, we would be able to find the equation for said line that goes through those 2 points, right? Okay, in this section, we're going to look at how to graph them, okay? And we're going to need this later on in section 2.3 when we actually start applying it to real world stuff, okay? Okay, so let me go ahead and recall some stuff, right? The linear function, right, is something that looks like this, right? The other way that people remember it is this, the y equals mx plus b, right? B is the initial or the starting value, right? The other thing we called it was the y-intercept, right? And then we had a slope, m, which was given by any one of these four equations for the slope, right? You can use any one of these four, right? And it would get you the slope, right? Okay, so let's first go to example 1, okay? And let's just start graphing some stuff, okay? So in terms of graphing, right, for any graph, not only for linear functions, but for any function you can possibly conceive, right, you can just grab x values, throw them in your function, get y values out, and you have an ordered pair, right? And then you can, if you slap enough of these down on a graph paper, right, they give you a graph. Okay, so let me demonstrate that just by doing this example right here. Okay, so suppose here's our function. I want to graph it, right? And I'm going to use my table, and then we're going to put the x and y coordinates on the graph that's right next to it on the right. Okay, so suppose for the first one, right? Let's say our x value is -10. Okay, so and that means my y value, right, is the same thing as doing this, right? Y is equal to 1/5 times 10, -10, right? Plus 2. Okay, 1/5 times -10, right? I'm gonna actually write it over here. That's gonna be -10/5 plus 2. So this is gonna be -2 plus 2 is equal to 0. So my x and y value here is gonna be -10, 0. Okay, we'll do it again for -5. So y is equal to 1/5 -5 plus 2. I'm going to do this thing again. So -5/5 plus 2. And this is going to be -1 plus 2, +1. So -5, 1 would be my coordinates that will go on my graph on the right. We'll put those down in a second. Okay, let's do one more. Let's do x is equal to 0, right? So y 1/5 0, right, plus 2. This is the same thing as 1/5 times 0. That's going to be 0 plus 2. Okay, and that is 2. So here I have 0, 2. Okay, so hopefully, right, if you're looking at this, you hopefully, I think you'll see that there's a pattern between the x and the y, right? So I'm going to go ahead and just finalize the rest of these flat out, okay? So you guys see how it goes, -10, -5, 0. The next one is going to be 5, and the next one after that will be 10. So then what are the y values? You see how they go, right? They started out at 0, then they went 1, 2, guess what? 3, 4. Okay, so if you go ahead and let me write this one out a little better. There we go. So if you actually complete the tables here, these are the points that you're supposed to be getting. Okay, all right, so now remember how I said if you just plug in enough x values and get y values, You get ordered pairs and slap enough of those on a graph paper, you'll get the graph, right? That's what we're about to do. Okay, so I'm going to use the purple for the point. So the first one is negative 10 comma 0. That's this point right here. Okay, the next point, negative 5 comma 1. Negative 5 comma 1, bam. Okay, the next one, 0 comma 2. The next one, 5 comma 3. 5 comma 3. Hopefully you guys see what's going on. 10 comma 4 is the last one I'm going to slap down. There we go. Hopefully you guys see, right? And I'm going to do this in blue. Hopefully the line shows up. If you just sort of connect the dots. Whoa. Maybe, a little better. Let's try it again, huh? 2, 3, 4, 5. Does it do it? Does it do it? Close enough. There we go. There's our line. It's supposed to go through all 5 points, right? Close enough. But there we go, right? No matter what, this method will always work for graphing a line, okay? Okay, so now, obviously, as you guys saw, right, I needed to do all of this. I needed to do all of this in order to graph a line, okay? This is way too much time for that. I don't got time for that. So there's got to be a better way, okay? This is where we're going to use the other interpretations of the parts of a linear function. We're going to use our b as the y-intercept, and we're going to specifically use our m as the rise over run. Okay, and this is how we're going to graph the point. Okay, so graph this function, right, without using a table. So that's what I'm about to do. Okay, so I'm going to go ahead and do this first of all. So my y-intercept, whoa, and let me turn that off. There we go. My y-intercept automatically is that tail. It's that +1, right? So my y-intercept is automatically going to be 0, 1. Okay. Now my m is my rise over run. And this is already given to us by this number right here, the -1/3. Okay. And what I'm going to do is this, and this is completely cool for you to do. Okay. I'm going to write the 1/3, right? And I'm going to do this. I'm going to do -1/3. I can give the negative to the top or the bottom. Okay. In this case, and I think this is the best way to do it for everybody in the class, give the negative to the top thing. Okay. And here's the reason why. Okay. This tells me my rise, right, divided by my run. So this is going to tell me to go down. The negative is telling me instead of rising, I'm going to be falling. I'm going to be dropping. Okay? Got it? Okay. To sort of generalize it a little bit, right? Like I said, I can give the negative to the top or the bottom, right? Let me erase the equal sign. The actual idea here, right, is if you give it to the, let's go ahead and do plus or minus divided by plus or minus, right? If you get the positive on top, right, that means you're moving up. If you get the negative on top, that's down, right? If you get the positive on the bottom, you move right. Okay, and if you get the negative on the bottom, that means you move left. Okay, so in this case, right, the -1 is on the top. That's telling me that I'm going to be moving downward. Does that make sense? And the 3 on the bottom is telling me I'm going to be moving, it's positive, so I'm going to be moving toward the right. Okay, so here we go. I'm going to start, I'm going to give this a purple point, okay? my y-intercept. I'm going to start with my y-intercept right there. Okay, and now I'm going to switch, and I'm going to do my orange dots to be all the other dots that I'm going to get using my slope. Okay, my slope is telling me to drop 1, move to the right 3. So from this point, from my y-intercept, I'm going to drop 1, move over 3. Drop 1, move over 3. So 1, 2, 3. Hopefully you guys see this. Drop 1, move over 3. You guys see the pattern that's showing up already, right? Okay. And hopefully you guys see the pattern. So the pattern downward, right, is just by going down 1 over 3, right? And hopefully you see the pattern that goes the other way, right? So it's supposed to be going this way, up 1, right? Over 3, up 1. Over 3, up 1. There we are. I think we've got enough, right? And now it's connect the dot. Oh boy. Now it's connect the dots, right? So I'm trying my hardest. Let's see if, there we go. Oh, there we go. Oh yeah. There we go. There's our line. Okay. Okay. So the next thing that's coming up is a quick check, right? I want everybody to graph these, right? Without using a table. Use the strategy that I used just right here. Okay. Should be simple. Okay. You can, as always, verify the answers for these using Desmos, and I encourage it. Please, please do. Okay. Okay, moving on. There are certain lines that I have to show you guys before we keep moving on, because they happen fairly often, not only in this class, but as you move into Calc 1, 2, 3, right? We need to be able to define these 2 lines, okay? And those are just lines that are horizontal, completely horizontal, and lines that are completely vertical, okay? A horizontal line, so a line that goes side to side, will be of the form this, just f of x is equal to b. That is it, okay? If you take a look at this, right, f of x is equal to b, right? And if you recall, right, the f of x gives you your y, right? So then the other way that you can write this, right, is y is equal to b, okay? This is telling you, right, that x can be whatever it wants, but y has to be b, okay? That is equivalent to this right here. So let's say that right there is b, right? This is going to be whoosh, there we go. So this would be f of x equal b. This is how we would signify a horizontal line, okay? Likewise, right, a vertical line would look like this. And the same would be said, just like we did with y equal b, right? In y equal b, x can be whatever it wants, but y has to be b, correct? In this other version, for a vertical line, your y value can be whatever it wants, but x has to be a, right? Does that make sense? So this is going to be this line, right? And then when we write x equal a, right, that's going to look like this. It's going to be a red line. And let's say this right here is a, right? That's this. Oh, I didn't want to fix it. It's something like that, okay? A line that's completely vertical at our value x equal a. That's it, okay? Okay, moving on. Something that is really, really useful later, if you ever study math or some of the hardcore physics later on in your studies, right, is the idea of parallel and perpendicular lines, okay? So let me cover the definitions for them first, okay? Suppose you had 2 lines, and notice how I have them sort of labeled here. F of x is the m1 of x plus b1, right? And g is m2 of x plus b2, okay? Both collections of m's, these m's right, can be anything they want. And these B's can be anything they want. Okay? Okay, so now, pretend you have two lines, right, F and G, okay? They are parallel if the slopes are equal. Okay? Two lines are perpendicular. We say that the definition behind perpendicular is that they meet at right angles. Okay? They are perpendicular if, when you multiply the two slopes, you get -1. Or equivalent, this is the thing that people usually remember from high school, one slope is the negative reciprocal of the other. Okay, I learned it this way, but if you remember this, the negative reciprocal thing, then that is fine with me. Got it? Okay, so what do these look like when you slap them down on graph paper, right? So if they're parallel, right, then you have this going on. One line's going to do that, and the other line's going to do the exact same thing that way. So this would be your g of x, basically, right? And this would be your f of x. Okay, if they're parallel, right, they will never meet. Ever, ever, ever. They're just going to travel in the same direction, and they will never touch each other. Okay, that is parallel. Perpendicular is the other way around. Okay, that they meet at a 90-degree angle. So I'm going to draw one line. So perpendicular would mean this, right? One line goes that way, right? And the other line, I'm going to try to do this as best as possible. Whoosh. Close enough. That angle right there, is 90 degrees. So it's exactly a right angle. Okay? That's what happens with parallel and perpendicular lines. So now, let's say I gave you guys some functions, right? Some linear functions. How can you determine whether one is parallel, perpendicular, or neither? And that's perfectly fine too. Okay? You follow the rules that were above it, up here. Okay? Parallel is if they're equal. Perpendicular is if they multiply to -1. And it's neither if neither one of them works. Okay? So let's go ahead and do this one. Okay? So automatically, right, this slope and this slope are not equal, so not parallel, right? So the only one that's left for us to check is the perpendicular. And that means I grab both the slopes, multiply them together. If I get -1, I get perpendicular. So I'm going to do 1/2 times -2. That is indeed -1. These two are perpendicular. Whoa. Let me turn off the ink to shape. There we go. So if you grab both of these linear functions and put them into Desmos, you'll see that they meet exactly at right angles. Okay? Next one. Boom, boom. The two slopes are not equal, so they're not parallel. Okay? And then if you do 2 times 3, that is 6. We need it to be equal to -1 in order for it to be perpendicular. So this is a neither. Since the slopes aren't equal and they don't multiply to -1, it's not parallel, it's not perpendicular, it's got to be the neither. Okay? And this one, the last one, hopefully you guys see the slopes. Both of the slopes are equal, right? So I'm going to just write it this way. M1 is equal to M2, if you call this one M1, M2, right? So then since both of those are equal, this is parallel. So parallel. Okay, so that means if you graph both of these on Desmos, what you should get is two lines that go exactly in the same direction. They will never meet, no matter how far you move away. Got it? All right. I'm going to have you guys try these out during lecture, during our time together. And I think after that is lecture questions. This is another quick section. Okay. If you have any questions about this, please ask me during class, stop me during class, or come visit me during my office hours, okay? Besides that, happy studying.